Okay, this is MAT 175, lesson 24, section 6.2, trigonometric functions, the unit circle approach. To start with, let's take a look at some basic concepts about the unit circle. We have some value t be a real number where we have a point xy on the unit circle. And on this unit circle, we have a radius of 1. So on here, if we were to say that, for example, here we have the unit circle of a radius of 1, and we have some value where we have our x and our y values, and we have our angle. Let's say this is, we'll go ahead and use theta for right now. Well, theta would correspond to this arc length right here, t, in radians. So we know that sine t equals to opposite over adjacent, over hypotenuse. Alright, we know here that sine t equals to opposite over hypotenuse. And so, since the radius is 1, the opposite side is y over the hypotenuse is 1, so we can say that sine t is equal to y. Cosine t is adjacent side over the hypotenuse. And the adjacent side is x, adjacent to our angle theta. Our hypotenuse is 1. So this would be the same thing as x over 1. And so cosine is synonymous with the x coordinate. So at this coordinate point xy, in trigonometry, we're going to replace that with cosine is the same as x, and sine is synonymous with y. And so we're going to use cosine and sine instead of x and y in our trigonometry relationships. Okay, so here's cosine t equals to x, and a tangent is sine is equivalent to y over x. So if we were to look at the unit circle again, here's theta. If we were to look at, and of course this would be t here, then, and this is y and this is x, tangent is opposite over adjacent. So that would be y over x. And we know that y is the same as sine, so we can say that tangent is sine t over x is the same as cosine, so this would be sine t over cosine t. And so we can say that tangent is also sine t over cosine t. The reciprocal identities, cosecant is the reciprocal of sine. So we know that sine t equals to y, so cosecant is 1 over y. And so we could also say that cosecant t is the same as 1 over sine t. So if we were to have, let's say, sine t were equal to, let's say, 1/2, then cosecant, since cosecant is the reciprocal of sine, then it would be 2 over 1, or cosecant we could say is 2. secant is the reciprocal of cosine. So if cosine t equals 2x, then secant t is 1 over x. So we can also say that secant t is equal to 1 over cosine t. So if we were to say that cosine t equals to, let's say, 5, then secant t is the reciprocal of cosine, so that would be 1 over 5, and so on. Cotangent is the reciprocal of tangent. So if here we have tangent t is y over x, then cotangent is x over y. And so we could also say that cotangent t is equal to 1 over tangent t. Since tangent is sine t over cosine t, then cotangent is going to be cosine t over sine t. Okay. Find the exact values of the trigonometric function using the point on the unit circle. Here we have a point, -1/2 square root 3 over 2 on the unit circle, which corresponds to some real number t. Now, t normally corresponds to radians, whereas theta normally corresponds to degrees. So here we have some value, -1/2 square root 3 over 2, a point on the unit circle. So we know that cosine is synonymous with the x-coordinate, sine is synonymous with the y-coordinate, so that we could say here that sine is the y-coordinate square root 3 over 2. Cosine t, that would equal to 1/2. And so tangent is going to be, tangent t is going to be sine over cosine. So we can say that would be the square root of 3 over 2 over -1/2. And so from here, we know that if we have, remember this concept, a over b equals to a divided by b. So if we took two rational expressions and we were dividing them, we know that we can apply the reciprocal to the second rational expression. So that would be a times 1 over b. So here in this case, if we have square root 3 over 2 divided by -1/2, then we could apply the reciprocal to the denominator, and we get square root of 3 over 2 times -2 over 1. And so now we can simplify that, and we get a negative square root 3 over 1, or just as negative square root 3. Okay, so, and that's what happens here. Alright, now the reciprocal identities, basically what cosecant is the reciprocal of sine. So all we're doing is we're taking sine and we're applying the reciprocal. So that becomes 2 over the square root of 3. But we have to rationalize that. So here, when we rationalize, we have 2 over the square root of 3. So we have to get rid of that radical somehow. So we can, if we were to multiply square root of 3 over square root of 3, we can do that because square root of 3 over square root of 3 is 1. So that becomes 2 square root 3 over the square root of 9, and so we get 2 square root 3 over 3. And that's what we get here. Alright, now also cosine is reciprocal of secant. So if cosine t is equal to -1/2, then secant t must equal to what? You should have said negative 2 over 1 or just a negative 2. Alright, and so that's what we get here. And now, what do you think cotangent is going to be? Well, since cotangent is the reciprocal of tangent, cotangent is going to be a negative. If this, we could say that this is a negative square root 3 over 1, then cotangent would be a negative 1 over the square root of 3. Well, do you think that's all are we finished here? Well, you should have said no, because we have to rationalize the denominator. So we have to multiply square root of 3 over square root of 3, and we get negative square root of 3 over the square root of 9, which is 3. And so we can see here that here's cotangent. They went ahead and applied, cosine over sine and simplified it, and we got, again, you have to rationalize here and we get negative square root 3 over 3. Okay, trigonometric functions of angles. Now here, in the unit circle, we have a radius of 1. So this is 1. If that's 1, this is also going to be a radius of 1 here. This is also going to be a radius of 1 here. And this will also be a radius of 1 here. So this point here, that'll be 1, 0. This point here, that'll be 0. X is 0, y is 1. This point here, what do you think that's going to be? You should have said negative 1, 0. And down here, what do you think this coordinate point is going to be? X is 0, y is a negative 1. And so we're going to look at that and come up with values for sine, cosine, and tangent for all of those. And we can also do the rest of them, the reciprocal identities too, if we wanted to, but which we will later. So in this case, here we show t is our measurement in radians, our angle in radians, and theta, we're going to use that as our angle in degrees. And we come up with some point AB on the unit circle. And so these are going to be our values as we're going through and working through problems. So all this is saying is just sine theta is equal to sine t. So in other words, we know that sine of, back up here, we know that sine here we go. Okay, we know that sine of 90 degrees, that would be theta, is the same as sine of pi over 2 in radians. And so that's all that's saying there. Alright, and so then cosine and so on. Alright, here we have our trig identities. We're looking at theta is 90 degrees, or t is at pi over 2 radians. And so we're just looking at this point right here at 0, 1. So we know that cosine is 0, sine is 1. So we can say that sine of pi over 2 is equal to 1. Cosine at pi over 2 is 0. And so tangent at pi over 2 is sine over cosine. And so since sine is 1, cosine is 0, we could say here that tangent is at pi over 2 is undefined. Okay, is undefined. So we have sine, cosine, sine, and tangent. Alright. For theta equals to 180, we know that is pi radians. Okay, and so this would be here t equals to pi, and theta equals to 180 degrees. And we know that this point right here is negative, x is negative 1, y is 0. So we know that sine is 0. Sine pi is 0. And we know that cosine pi is negative 1. So again, tangent is sine pi over cosine. So this would be 0 over negative 1. Well, 0 over negative 1 is 0. So tangent, so we could say that cosine is negative 1, sine is 0, and tangent is also 0. Okay, now for 270. So here, this would be t. And t is 3 pi over 2. So it's like 3/4 of the way around. Here's pi, and here's 2 pi. So this is 1 pi, and this would be like 3, or not 3/4, but 3/2 of the way around. And so this is also 270 degrees. 180 degrees, 90 degrees. And so this is pi over 2, so we would say that 270 would be 3 pi over 2. So we know that this is cosine and sine. So we know that sine at 3 pi over 2 is negative 1. Cosine at 3 pi over 2 is 0. And so tangent is going to be sine of 3 pi over 2 over cosine. 3 pi over 2 is going to be negative 1 over 0. And so, again, 0 is in the denominator. That's undefined. So tangent would be undefined at 3 pi over 2 or 270 degrees. Okay. And so now, at here, we are at 2 pi. Now, we could also look at this as 0. And so this would be 0, and then we know this is 90, or pi over 2, and this is 180 degrees, or pi, and here this is 270 degrees, or 3 pi over 2, and we're back to doing a complete circle, and this is 2 pi, or 360 degrees. Okay, so here we have cosine, sine, and we're going to find tangent here. Okay, so sine at either at 0 degrees or 0 radians, and also at 2 pi radians has a value of 0. And cosine at 2 pi radians is 1. So tangent is going to be sine over cosine. That'll be 0 over 1, and so we get 0. So here, tangent, we can say, is 0 for cosine, sine, and tangent. Right. And here it lays it out in this chart. This is basically the same thing that we just did with the unit circle, where we had 1, 0, 0, 1, -1, 0, 0, -1 for cosine and sine, cosine, sine, cosine, sine, and then of course tangent. And so this is basically laid out in table format for 0, pi over 2 pi, 3 pi over 2, and 0, 90, 180, 270. So it's just a table format of this, what we just constructed. Okay, we're going to do these in class. Okay, let's take a look at right triangle trigonometry. Here we have a right triangle, and here we have this perpendicular. We know that the height is perpendicular to the base, and we have the hypotenuse. So, and we have an angle theta here. So opposite side is the side that's opposite of angle theta. It does not touch angle theta. The adjacent side does touch angle theta, but the difference between the adjacent side and hypotenuse is the hypotenuse is always opposite the right angle. And the hypotenuse, of course, is always the largest of the three sides. Okay, so if you're trying to identify, which is the opposite, adjacent, and hypotenuse, good idea to always start with, where's your hypotenuse? It should, it's always opposite the right angle. So look for that first. Okay, so with that, we come up with our sine, cosine, and tangent for right triangle trigonometry. And there's a way that you can, a mnemonic device or a memory device called SOHCAHTOA. And S stands for sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent in our right triangle. So if we were looking at a right triangle here, and we have our angle theta, and we have our hypotenuse is opposite the right angle, we have our opposite side and our adjacent side, then sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. Okay. So we said before that the reciprocal identities are cosecant is the reciprocal of sine. So since sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Cosine is adjacent over hypotenuse, so secant is the reciprocal of cosine, so that'll be hypotenuse over adjacent. Tangent is opposite over adjacent, so cotangent is reciprocal of tangent, so that'll be adjacent over opposite. So we're going to be looking at finding the values for all 6 trigonometric functions, and so it's easiest to find sine, cosine, and tangent first, and then all you have to do is just apply the reciprocals to each one of the reciprocal identities, and that's it. It makes it a lot easier doing it that way. Okay, find the exact values of the trig functions. Alright, here we have an equilateral triangle where we have one side here. This is actually 60 degrees here. Use red. 60, so it's always going to be 60, 60, 60, and 1, 1, and 1 for sides. And so the sides are always the same for an equilateral triangle, and all the angles are always equal. So the angles would all have to be 60, 60, and 60. Well, if you take a line and bisect this top angle here, then you have 2 equal angles and 2 equal sides. So if this is 1, then that makes this side here 1/2, and this side here 1/2. So now if we take away one of these sides, we have here 1, and this is 1/2, so we have to find the third side. So if we applied the Pythagorean theorem here, and we went ahead and said, okay, a squared equals to b squared, a squared equals to a squared plus b squared equals to c squared. C is always the hypotenuse. Well, a is 1/2, so that would be like saying 1/2 squared plus b squared equals to c is 1, so that would be 1 squared. And so we get 1/4 plus b squared equals to 1. So if we apply a minus, if we're solving for b, we apply minus 1/4 to both sides. And so if we change 1 to 4/4, we can see that 4 minus 1, that would be 3. So b squared equals to 3/4. So here we have b squared equals to 3/4. So if we apply the radical to both sides, and we get plus or minus square root of 3/4. Well, we don't have a negative value for a measurement, so we drop the minus and we just say the square root of well, this would be the square root of 3 over the square root of 4 would be the square root of 2. I mean, it would be just 2. Okay, and so we get this value here for this 60, 30, 90 right triangle. If we look at, so this is fundamental here. We have this right triangle, 60, 30, 90. And so if we were to go ahead and reconstruct this, we can say that this would be 1/2, 1, and square root 3/2. And so another way that we can look at this is if we were to reconstruct this, we could always use this 60, 30, 90 right triangle, and here we would remember that opposite of 60 is square root 3/2, adjacent to 60 is 1/2. And so we could say that sine of 60 degrees is opposite over hypotenuse. We could say that sine of 60 degrees is square root of 3/2. Cosine is going to be adjacent over hypotenuse, so that we could say that cosine of 60 degrees is 1/2, and so on. Okay, so here we have our right triangle on the unit circle. And so, this would normally be 30, but we're just looking at 60 for right now. So that's our right triangle, and again, square root 3/2 and 1/2. And so we could say that the sine is square root of 3. Sine is opposite over hypotenuse, so that would be square root of 3/2, and so that would be square root of 3/2 for our sine, or our y coordinate. And our cosine is adjacent over hypotenuse, so that would be 1/2. Cosine of 60 would be 1/2 over 1, or just 1/2. And so we could also say tangent is sine over cosine. So that would be square root 3/2 over 1/2. So we could say that would be square root of 3/2 times the reciprocal of 1/2. We just apply the reciprocal, and that would be 2/1. Well, the 2's cancel here, and we get the square root of 3. So we can say here that tangent is square root of 3. So these are values here that we want to remember, and we want to commit this to memory. So these are fundamental values here that we must remember, because we will be using these over and over and over again. So these values here, these are like multiplication tables in arithmetic. These are something that we need to commit to memory. Okay, so sine is the square root of 3/2, and we know that cosine is 1/2. So cosecant is reciprocal of sine. So we apply the reciprocal, we flip that, right? And we get 2 over the square root of 3. Well, we have to rationalize it. Square root of 3 over square root of 3, and we get 2 square root of 3 over the square root of 9 is 3. Back up here. secant is reciprocal of cosine. So secant of 60 degrees is going to be, since cosine is 1/2, secant is going to be 2 over 1, because we're just going to apply the reciprocal, and we get 2. And then tangent, okay, and then we already worked through that. We got square root of 3. So cotangent, basically we can take this and apply the reciprocal to that. Well, here we have to go ahead and rationalize that, so we have to multiply. So let's look at this off to the side here. We're going to take 1 over the square root of 3, and we're going to multiply square root of 3 over 3. And so square root of 3 over the square root of 3. And so we get the square root of 1 times the square root of 3 over square root of 3 times 3. And that would be the square root of 3 over square root of 9. And so that would be square root of 3 over 3. Okay. So with this, let's back up here. We're going to take a look at pi over 6 is equivalent to 30 degrees. Now, in our previous triangle, we said that 60 degrees opposite was square root of 3 over 2, 1/2, 1. So, and this was 30 here. So basically, all we're doing here is we're taking 60 and 30 and switching places. Well, the values are also switching places. So now for 30, since here 30, the opposite of 30 is 1/2, well, here's opposite of 30 is 1/2. The adjacent of 30 is square root of 3 over 2. Here it is, adjacent is 30 is square root of 3 over 2. The hypotenuse stays the same. So sine for 30 is opposite, sine for 30 is opposite over hypotenuse. So that would be 1/2 over 1, and so that's 1/2. Okay, so there's sine of 30 degrees. And then cosine is adjacent over hypotenuse, so that would be square root of 3 over 2 over 1. And so that would be square root of 3 over 2 for cosine. And for tangent, then that would be tangent of 30 degrees. That would be sine over cosine, sine of 30 over cosine of 30 degrees. And so that would be 1/2 over square root of 3 over 2. And so this would be 1/2 times, we apply the reciprocal to our denominator, so that would be 2 over the square root of 3. And so we can cancel here the 2's, and we get 1 over square root of 3. But what do we got to do now? We got to rationalize, right? So we got to multiply square root of 3 over the square root of 3, and we get square root of 3 over the square root of 9, which is 3. Okay, so that would be tangent for 30 degrees. Alright, so with that, that's what we get here. So since cosecant is reciprocal of sine, since sine is 1/2, then cosecant is going to be 2. We just apply the reciprocal. Since cosine is square root of 3 over 2, secant is the reciprocal of cosine. So secant at 30 degrees is going to be, since we have square root of 3 over 2, then the reciprocal is going to be 2 over square root of 3. So we have to multiply square root of 3 over square root of 3 here. And so we get 2 square root of 3 over the square root of 9, which comes out to be 2 square root of 3 over 3. And then tangent, again, here we go. Well, we did this already, sine over cosine. We get tangent for 30 degrees is square root of 3 over 3. Okay, so cotangent is going to be, if we looked at this part here, 1 over square root of 3, and we apply the reciprocal to that, we can see we get the square root of 3. Instead of applying it here and then have to rationalize again, we could just do it here and then flip it, and then we just get the square root of 3, and that makes it easier. Okay, so for 30 degrees, we have cosine, sine, and then tangent we have is square root 3 over 3. So these are basic these are basic values that we need to commit to memory for 30 degrees. Okay, now for 45 degrees. For a 45 degree right triangle, 45 degrees, we have 1, 1, square root of 2. Okay, and so for 45 degrees, sine is opposite over, so we could say sine of 45 degrees is equal to opposite, which is 1 over square root of 2. But again, we have to rationalize the denominator, so we have to multiply square root of 2 over square root of 2, and so we get square root of 2 over the square root of 4. Well, square root of 4 simplifies to 2. So that becomes 2 square root of 2. Well, cosine is 1 over the square root of 2, so that also becomes square root of 2 over 2. And so we've got cosine, the square root of 2 over 2. Sine for 45 degrees is square root of 2 over 2. Well, let's see. What about tangent? Well, tangent of 45 degrees is going to be sine 45 degrees over cosine of 45 degrees. So that's going to be square root of 2 over 2 for sine over square root of 2 over 2 for cosine. And so those simplify out to be 1. So tangent at 45 degrees is 1. And so with that, we look at the other 6 trigonometric functions, and we get here's sine, so cosecant is going to be the reciprocal of that. So if we were to apply the reciprocal there, we get this would be, we flip that, and we end up with 2 over square root of 2. Well, we rationalize that, multiply square root of 2 over square root of 2. And so we get 2 square root 2 over square root of 4 is 2. And so the 2's cancel, and you just get square root of 2. And that's where that came from. Well, secant is the reciprocal of cosine, and you're going to get the same thing there. 1 over square root of 2 over 2, and so that becomes just the square root of 2. Well, since tangent is 1, the reciprocal of 1 is just 1, so cotangent is also going to be 1.